All right. So think of this as like an exam, like a final exam. This is just, I mean, it's not like you're going to class and there's anything riding on it. This is a completely stress-free environment. Um, but think of it like a cumulative thing. Like you've been doing all these things and now we're putting them all together. So far, you've shown mastery of each thing individually, and you fixed the part when we met yesterday about uh, knowing when to add or subtract to finish your equation and how to check it. Just to review, your rise and your run, we are working backwards, so that's why it's flipped. X is not on top and Y is on top instead, because you have to work backwards if you're given a line to work backwards to get it. Uh, M is going to be your slope, and B is going to be your starting point, your y-intercept. Whenever we have a y equals like 2x plus 2, that y is going to be an output. That means whatever we solve over on the right side, the 2x plus 2, whenever we input an x and we solve it, it's going to generate a number for us, and that's going to be our y value. That's why it's called an input is your x. You put it into the equation, you solve it, and then you get your output. Just to review, I want to go through everything we've done, and then I'm going to show you the template we're working through. Uh, Slope. All right, so we went from having a line and 2 points to determining what the major parts of the equation were. So to find the slope, all we did is count how far down did we have to go to line up to the other point, and then how far over. We went 1, 2, so -2 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over 10. And of course, I'm going to always ask you the question, if you're ever seeing a fraction or a ratio, you can always simplify that, and that'd be a slope of, -1 over 5. So whenever we're plugging it into our equation, notice that there's always x next to it. Okay? And this is where we got yesterday when we were talking about plugging stuff in for x. And then what do you add or subtract to get there? The other telltale sign of a y-intercept is where is it crossing through the y-axis? It's crossing through at -2. Okay, so that would be right there. And we finished our equation. Y equals -1/5 x minus 2. That's what this line is telling us. Is there more to this? Absolutely, but this is where we're starting. So that's how to write an equation from a line. So what about when we have an equation and we need to write a line? Okay, so we know the parts slope and y-intercept. Always start with your y-intercept at +1. We know that underneath every whole number is a 1, so that's a rise and run, a rise of 2, a run of 1. 1, 2 over 1. 1, 2 over 1. To reverse it, down to left 1. You can see how it follows the trend of the line. Okay? The thing that is going to come up again is we just generated these coordinates. So you could actually identify your y values, and you'll see that it's crossing through at 0, +1. And you'll know that it's increasing by 2 every time you move over one x value. So that would be 3, 5, and 7. You always want to check these, which is what leads us to the next part, is if you have x values and you have an equation, you don't really need to do anything crazy. All you do is use the equation in your input values, which is your x. So check this out. This is something you said was pretty easy, and what this does is generate our y values. So 2 times 0 is 0, plus 1 is 1. And look, that coincides with 0, 1. That's where that's crossing through. That's our y-intercept. That's our y-intercept. That's our y-intercept. Anytime that you put an x value of 0, you're finding a y-intercept. And then just continue to substitute. 2 times 1 plus 1 is 3. You see it increase by 2, just like our slope. So then we have over 1 up 3. 2 times 2 plus 1 equals your y value, which is 5. You can see it increased by 2. So that's that one. And this continues on and on and on. This is how you know you're on the right track. All of these methods combined will make sure that you have a 100% chance of getting all of this correct. Okay, so what we did last time, is we went through these 5 steps, and this is where you had the problem. That's what we clarified. Everything else up to that point was fantastic. So you find out what your y is changing by. You find out what your x is changing by. There's your rise and your run. Okay, so you had 1 over 1, and we can always simplify. That equals 1. So we have 1x. Now we're going to use our y equals 1x, and we're going to substitute our x values in and see if it equals our y values. So I'm going to start with 1. Y equals 1 times 1. That is 1. And how do we get to 2? We have 1. How do we get to 2? Plus 1. And we just wrote our equation. Okay? And we can always go back and check it because that's what I highly encourage you to do. I'm going to use 2 with our equation we just wrote. So 1 times 2 is 2, plus 1 is 3. Check. Now we know we're correct. And I'm just going to be crazy and annoying because I'm an old person. I'm going to just go ahead and substitute 3. 1 times 3 is 3, plus 1 is 4. Cool. Double checked. Now, what happens when we do everything? Okay, so this is a blank template of what you're going to be looking at. Basically, what you're going to be drawing is a 4 square. I have a sheet of paper on another slide, and I'm going to show you exactly how you can arrange this and orchestrate all the things that you're trying to do. But you're either going to be given the equation or the line or what you're substituting, and you generate your y values, then you can plot them. Or you use your substitution to generate y values and then rewrite the equation in all the critical parts of the line itself. Let's take a look at an example. So here's one that's completed. This started with only this line, okay? And then I put this line, and then I did all this other stuff. So I wanted to go over what substitution looks like and what a completed one looks like. So I'm gonna finish this one in its entirety right now. So substitution, we're taking our x values and we're putting it in to our equation. And we're gonna end up outputting y values. 3 times -1 is -3. -3 minus 1 is -4. You should be able to check at -1, you have -4. Check. And that is another way. You go -1, -4, and you plot the point, and you're already making your line. 3 times 0, and this is where our y-intercept would be, because when x is 0, that's how we know where the line's going to be. So 3 times 0 is 0, minus 1, -1. 0, -1. Check. 3 times 1 is 1, minus 1, or wait, 3 times 1 is 3, minus 1 is 2. So 1, 2, over 1, up 2. Check. 3 times 2 is 6, minus 1 is 5. Check. 3 times 3 is 6, or 9, minus 1 is 8. You can see this increased by 3 the whole time. And that's what our slope was. It went up by 3 over 1. Okay, and right here, this is where this all connects. When your x is 0, you have your y-intercept, 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 y-intercept. All of these things coincide with each other, and we're just looking at them in different forms. If you're able to make these things happen in these 4 corners, then you're going to have an understanding that no one else in your class is going to have. So what I want to do is I want to go through each one, generating, like just given one piece, what would it look like to get the other 3? And then I'm going to move on, and I'm going to have a different piece with a different problem, and I'm going to generate the other 3, and then again and again until all 4 combinations are done. And then I'll review on how I'd like you to do this. Another suggestion I have is when I'm doing this, hit pause and see which sections you feel like you can do. And then you can know what you need to focus on whenever you're going through the instructional part of this. So right now we know that we have y equals 2x minus 3 is given. Okay. So I'm just going to go ahead and write down the facts about this equation. I know that the slope is 2 over 1. I know that my y-intercept is -3. And I know that since this is positive and my slope is positive, I got a positive line. Super easy. If I wanted to, which I can, I could make the line already. So I know it starts at -3. I know it goes up 2 over 1. There you go. And the alternate to that is, say if I didn't want to do it like that, I could just substitute all my stuff in. 2 times -1 minus 3, 2 times 0 minus 3, 1 minus 3. Two times -1 is -2 minus 3, -5. Okay, and that would have been right there. And this is our y-intercept, so that's going to be -3. There it is. 2 times 1 is 2, minus 3 is -1. Check. And you see how I'm generating the x and y coordinates? They're just simply, you could plot those right here, and that would take care of that. This process is going to continue, and I'm just going to be as thorough as possible. 2 times 2 is 4, minus 3 is 1. 2 times 3 is 6, minus 3 is 3. Okay? You can see that it increased by the slope. Easy peasy. Now what does it look like when you're given a different section? So you're only given the bottom left. All right, well, what does that look like? Well, I know some stuff. All right, I know that whenever I have a slope, I know that my slope is always going to have x next to it. Okay, and I just got that from right there. I know that my y-intercept is going to be the thing that's either added or subtracted. Boom, I got the equation. Okay, and I know that it's positive because my slope is positive. If there were a negative in front of that too, then this would be over there. You could go the same route that we went last time. What I'm going to do is, instead of drawing the line first, I'm going to do the substitution first and use those coordinates to plot a point. All you have to do is plot 2 points and you have a line. So 2 times -1 minus 3. And, you know, I really do hope that you are pausing this and trying to generate these coordinates before I ever have them. Because there's not going to be any shortcuts for this. If you value going into class and knowing and it being easier and you have an understanding of it, you're not just doing it, then you'll take the time to do this and not cheat yourself. 2 times -1 is -2, minus 3, -5. 2 times 0 is 0, minus 3, -3. And you can see, there it is, there it is, there it is, and it's going to be right there. 2 times 1 is 2, minus 3, -1. 2 times 2 is 4, minus 3, 1. 2 times 3 is 6, minus 3, 3. You can see it's increasing by 2, just like our slope says it would. So I'm going to pick 3, 3, just randomly from our table. There's a line crossing through at -3. And that's a positive line with the slope of up 2 over 1, up 2 over 1. There you go. So what does it look like if we're given just a line? Well, this goes back to, can we write an equation from a line? Absolutely. So we went with this section and this section in combination a while back. All you got to do is find your slope. Okay? So all we do is count the rise over run. 1, 2, 3, 4, 5, 6, 7, 8. All right, so 8 over 1, 2, 3, 4. Okay, 8 over 4, that translates to 8 divided by 4, which is 2. And we could do 2 over 1, or just 2. So right now, here's what we've got. That's our slope, right? We know it's a positive line. And where's it crossing through? Where's the line crossing through on the y-axis? So here's how you would go about doing this to check it. Follow your slope. 2 over 1 or just 2? Up 2 over 1. Bam, there it is. Proof. -3, -3. Cool. We have 3 sections done already. Now we prove it, because every single one of these should work out and coincide with everything next to it. Negative 2 times negative 1 is negative 2 minus 3 negative 5. This is our y-intercept, so we know it should be at negative 3. 2 times 0 is 0 minus 3. Bam. 2 times 1 is 2 minus 3, negative 1. Then 4, 1, and 3. All of these connect together. And if you find another way of using this line to make this, or you've got 2 coordinates, like you went to negative 1, negative 5, there's another way. I mean, like, so look, instead of doing the substitution part, you're still doing the substitution part, but I'm talking about like just using a different route to get there. Say we haven't done the table yet, but you're given a line, and you've got 2 points on it already. So when x is negative 1, where's y? Negative 5. And then you have 3, 3. Now you can use this to find your equation if you wanted to, like, what's it changing by? How do you go from negative 5 to positive 3 plus 8? Oh my gosh, look at that. Positive 8, positive 8. And what's this changing by? From negative 1 to positive 3 plus 4. Oh my gosh. Okay. So, and then you start substituting x values in, and you're like, okay, well, how do I get from, so let's just take a look at this. So we'd end up having this. 2 times 3 is 6, but how do you get to 3? Minus 3. Boom, you found your y-intercept. Okay? It's like all the combinations of everything we've done. Last part, you are given, these red dots aren't supposed to be there. I think I just didn't delete them. I don't know. But you're substituting your stuff in. And you can already tell from the equation that's here what the equation is. It's 2x minus 3. Okay? And then you can substitute your stuff in however you like. Okay, I'm just putting the y-intercept because I already know what it is. And then you can go up 2, and you can already have your coordinates generated. So 0, negative 3, 2, 1, 1, negative 1, and 3, 3. And that one's going to be negative 5. But substitute them all in, solve it, make sure those answers check out. All right, so what is it that you got to do? Here's a sheet of paper, right? Here's what you're going to do. You're going to go boom, boom. This is one problem. Okay, you're going to have your equation here. So what you're going to be doing is you're going to be looking at a blank template. It's going to have one piece filled in, just like the four slides I just went over. And for a table, here's all you have to do for your coordinate plane. If you have an equation that says x plus 2, okay, you would go up there, because that's about where 2 is at, and then you'd say it's going up 1 over 1, okay? That'll give me the idea that you know where the y-intercept is and what type of line it is. That's all I'm looking for. Now, don't notice I didn't put any numbers. If you want to be thorough and put numbers, go for it. For your table, all you got to do is x, y, substitute x plus 2, x plus 2, x plus 2. If you want to use 0, 1, 2, 3 as your x values, do it. I always encourage you to use 0. And then for down here, all you need is M, B, and positive or negative line. That's it. So if you have questions, please just shoot me a text and ask a question. Completely okay. We can meet. We can go over it again. Give it your best try. And in addition to these 4 templates, they're all going to be different. So it's not going to be one problem leading into the second. It's going to be like an equation, and all of that goes together. And then the next problem is completely different. Nothing's the same. Okay. And I mean, like the template I went through here used the same equation in all four of them. That's not going to be the case. This will be a problem. This will be a separate one. This will be a separate one, and this will be a separate one. So don't think that they're all connected. All right. Let's give it a go. Let's see what you know.